Hi students, today I am going to make the video on the much awaited nanomaterials. So in this video I am going to explain one of the preparatory method or synthesis of the nanomaterials, that is wet chemical synthesis or sol gel method. So before I explain this wet chemical synthesis or sol gel method, in order to understand this particular synthesis or preparation or any of the preparation or synthesis of the nanomaterial, some basics related to the synthesis or the preparations are needed. Those basics are the two approaches by which we can synthesize or prepare the nanomaterials. So there are two approaches by which we can prepare or synthesize the nanomaterials. The one approach is top-down approach. The name itself suggests that we are going to convert the macro, which is top to down, microscopic material. So this particular approach, of which is one of the preparatory method of the nanomaterial, involves the conversion of macroscopic materials into microscopic materials, which are in the range of 1 to 100 nanometers. So 1 to 100 nanometers means whatever the materials which are going to be obtained during this approach are nanomaterials, because nanomaterial ranges from 1 to 100 nanometers. So for example, for making the sculpture, the raw material, the starting material is the rock. By carving the rock, the bigger rock, the microscopic rock, the sculpture is being designed. The sculpture is very short, microscopic in nature, microscopic in size. So carving a rock into the sculpture is just like the top-down approach. Now coming to the next approach by which we can synthesize or prepare the nanomaterial is bottom-up approach. Bottom-up approach. The name itself suggests that this particular approach, which is one of the preparatory or synthetic method for the synthesis or preparation of the nanomaterial, involves the conversion of microscopic material into macroscopic material. And this macroscopic material means it is not bulky in nature. It should be in the range of 1 to 100 nanometers only, because by using these two approaches, we are going to design or synthesize or prepare the nanomaterials. So macroscopic material only. By using this bottom approach method, we are going to convert the microscopic into macroscopic. Doesn't mean that we are going to convert them into the bulk materials. This will be in the range of 1 to 100 nanometers. So based upon that, we can say that by means of bottom-up approach also, we are going to prepare the nanomaterials. And to exemplify this bottom-up approach method, so for the construction of the building, brick is needed. Brick is microscopic. And the building is being constructed by placing brick on the brick, brick on the brick, brick on the brick. Ultimately, we will construct the building which is macroscopic in nature. So this is just an analogy, right? So conversion of the smaller materials into the bigger material is nothing but bottom-up approach. So these are the two approaches by which we can synthesize or prepare the nanomaterials. And these two approaches can be illustrated by the following figure. So, dear students, as I said that top-down approach involves the conversion of macroscopic to microscopic, whereas the bottom-up approach involves the conversion of microscopic to macroscopic in the range of 1 to 100 nanometers. So accordingly, we can say that this particular phenomena, which is top to bottom, so bulk material, Bulk material is converted to the powder. Bulk material. So this is top. Bulk material is top. It is converted initially to the powder. Now this powder is being converted into the nanoparticles. So see the size. It is bigger. Now bigger is converted to the powder, which is smaller than the bulk. Now this powder is being converted into the nanomaterial, which is at the nanoscale within the range of 1 to 100 nanometers. So top to bottom. Top to bottom. Now from this approach, top to bottom, this approach is called as top-down approach. Top-down approach. Now, in the case of this particular approach, so what we are doing, the conversion of the atoms which are microscopic particles are being converted into macroscopic, which are nanoparticles within the range of 1 to 100 nanometers according to the definition of bottom-up approach. This particular outline is nothing but bottom-up approach. Bottom-up approach. Right. So I hope you understood what is top-down approach and bottom-up approach. Now, why I have explained this top-down approach and bottom-up approach, which are the two approaches by which we can synthesize or prepare the nanomaterial initially, before going to explain the wet or wet chemical synthesis or salt gel method. So do remember that this particular salt gel method comes under the category of bottom-up approach. That is, we are going to convert the atomic sized particle into nano-sized particle within the range of 1 to 100 nanometers. Now let us come back to our actual topic. Actual topic is wet chemical synthesis or salt gel method. Now first let us see why it is called as wet chemical synthesis. This particular synthesis or preparation of the nanomaterials is called as wet chemical synthesis. The reason is, this particular synthesis or preparation of nanomaterials involves the chemical substances in the wet nature. That is, whatever the chemical substances which are a part of this particular wet chemical synthesis will be in the wet condition. That is, moisture is associated with the chemical substance. That is the reason this particular synthesis is called as wet chemical synthesis. Now, what is another name for this particular wet chemical synthesis? Another name for this wet chemical synthesis is the salt gel method. Now we have to discuss why this particular synthesis is called as salt gel method. This is because during this synthesis or preparation of the nanomaterial, salt, which is the colloidal suspension, is being converted into gel. That is, the salt to gel transition takes place during this particular synthesis or preparation of nanomaterials. So that is the reason this particular approach, this particular method, which is one of the synthetic pathway to achieve the nanomaterials, is called as salt gel. Now do remember that this particular method is especially used to prepare or synthesize the nano-sized metal oxides. And the precursor which is being used in this particular wet chemical synthesis in order to prepare the nano-sized metal oxide is metal alkoxides. Metal alkoxides are the precursors. What is the meaning of precursor? Precursor is the starting material of the reaction which undergoes change. Precursor is the starting material of the reaction which undergoes change. Now here, the precursor is the metal alkoxide. Metal alkoxide. What is the general structure of metal alkoxide? I will explain later. So precursor is metal alkoxide. Now, this should be actually dissolved in the water. This should be actually dissolved in the water. Metal alkoxide should be dissolved in the water. Why it should be dissolved in the water? Because the water in this particular synthesis is a catalyst. So that is the reason metal alkoxide, which is a precursor in this particular synthesis, should be dissolved in the water. But this metal oxide, whenever it is dropped in the water, it is not soluble in the water. So what we have to do in order to facilitate the dissolution of metal alkoxide, we have to take the beaker in which we have to consider some amount of alcohol, and in which we have to drop these metal alkoxide powder. So whenever the metal alkoxide powder is dropped inside the beaker comprised of the alcohol, as the metal alkoxide is soluble in the alcohol, it gets soluble in the alcohol. Once it undergoes dissolution completely in the alcohol, then we have to add the water to it. Now, why the water is added? Because it is a catalyst in this particular synthesis. Now, this particular solution, that is metal alkoxide in the water, before that what we are adding for the dissolution, in order to ensure the dissolution of the metal alkoxide, we are adding the alcohol. Now, this is a combination of the three: metal alkoxide, alcohol, and water. Right. Now, what we need to do is, so before that, this is the homogeneous solution. This is the homogeneous solution, that is, the solute is completely dissolved in solvent. Homogeneous solution. Now, this should be continuously stirred. This should be continuously stirred. Whenever it is continuously stirred, the metal alkoxide reacts with water molecules. And what is the role of water? Catalyst, right? Reacts with water molecules and undergo hydrolysis. What is hydrolysis? The reaction of the substance with water is nothing but the hydrolysis. Now, what is happening here? Metal alkoxide is reacting with the water molecules. That is the reason this particular step is called as hydrolysis. Now, whenever this hydrolysis reaction takes place between the metal alkoxide, which is the precursor, and water, which is the catalyst, results in the formation of sol. Now, what is a sol? Sol is metal hydroxide. What are the chemical reactions involved in this particular synthesis? I will explain later. Metal hydroxide is going to be resulted, and this metal hydroxide is not soluble in the water. It is not soluble in the water. So, since it is not soluble in the water, we can say that it is the colloidal suspension of metal hydroxide which is so formed in this step in water. It is a colloidal suspension. Now, what is the difference between the normal solution and the sol? In the normal solution, the solute undergoes 100% dissolution in the solvent, whereas in the sol, the solute, what is the solute here? Metal hydroxide will not undergo 100% dissolution in the water. It will be in the heterogeneous state. It will be in the heterogeneous state. So, sol is formed. Now, sol, what we have to do is, we have to keep the sol undisturbed for hours to days, for 1 day or 2 days. We have to remain this particular sol undisturbed. We should not disturb the sol. Now, whenever we are not going to disturb the sol, what happens? The aging of the sol takes place. Because aging means the duration is increasing, right? So, aging means what? The duration is increasing. So, whenever the duration is increasing, now the sol will be converted into gel, because some of the water molecules will get evaporated. some of the water molecules gets evaporated, and this phenomena is called as condensation. So some of the water molecules are evaporated, and these salt particles gets condensed into each other. Gets condensed to each other. That is the reason this particular step is called as condensation reaction. So during the condensation reaction, the salt is converted to gel. Salt is converted to gel, students. And this gel is homogeneous. So initially it was homogeneous. It has been converted to heterogeneous. Now again it has been converted to homogeneous due to the formation of metal oxygen bond. Now how the metal oxygen bond is going to be formed, I will discuss later during the illustration of the reactions. Now gel is formed. Now in the gel, MOM bonds will be there. MO bonds, that's M means metal, O means oxide. Metal oxide, metal oxide, metal oxide, metal oxide. The polymerization of MOM will take place. So due to the polymerization, the nanomaterial is going to be formed. Nanomaterial is going to be formed. Nanomaterial has been formed, students. What is that nanomaterial? This particular synthesis is helpful for preparing the nano-sized metal oxide. So nano-sized metal oxide has been formed, students. Now what we need to do? We have to extract the nanomaterials. We have to extract the nanomaterial means we have to extract the nano-sized metal oxide which has been formed. For the extraction, what we need to do? We have to dry the gel. We have to dry the gel. So before that, students, what happened during this particular synthesis or preparatory method? Salt is transformed into gel. So since salt to gel is converting, that is salt gel transition is taking place, that is the reason this particular method is called as salt gel method. Right. Now drying of the gel gives actually our nanomaterials. Right. Now drying means what we need to do? We have to eliminate the solvent molecules associated with our nanoparticles in order to extract our nanomaterials which have been formed during this particular synthesis, because the nanomaterials have been formed, students. In fact, nano-sized metal oxide have been formed, but they will be along with the solvent molecules. What are the solvent molecules? Alcohol. Initial step, right? Initially what we have done? We have added the alcohol to the precursor in order to facilitate the 100% dissolution of the precursor. Now we need to remove the alcohol content from the nanomaterials which have been formed in order to isolate the nanomaterials individually. So that is the reason we have to do the drying of the gel. And the drying of the gel can be done in 3 ways. One is by maintaining supercritical conditions. Supercritical condition. What do you mean by supercritical condition? Whenever the compound in this nano structures or nanomaterials, whenever the nanomaterial is subjected to temperature and pressure above its critical point, that particular condition is called as supercritical condition. Now, whenever supercritical condition is being maintained, that is the temperature and the pressure is being maintained in order to extract the nanomaterials from the gel beyond the critical point, then that condition is supercritical condition. So, under the supercritical conditions, we are going to get the aerogel, which is our nano-sized metal oxide. We got aerogel, right? and morphology is retained, students. Morphology is retained. What is morphology? The shape and size of the material. Shape and size of the material is morphology. And during this particular supercritical condition for drying of the gel, in order to extract the nanomaterials individually along with the alcohol, aerogel is formed and the morphology is retained. Morphology is retained means what, students? Morphology is retained means the size and shape of the nanomaterials which are going to be formed from the gel is not being altered. So based upon this, we can say that whatever the nano-sized metal oxides which are going to be formed by maintaining the supercritical condition is highly pure, because it is retaining the morphology, it is retaining the size and shape. It's 100% pure, we can say that. Whenever it is 100% pure, why we are not going only with the supercritical condition? Because in this method we need to maintain the temperature and pressure of the material beyond the critical point. It is not that easy, students. So it is not a economical method. It is non-economical method. That is the reason it is not being used. It is not being used. It is not being used means what? It is not being used frequently, but it is used, but in the most frequent manner it is being used. Whenever we want to retain the nano-sized metal oxide from the gel, then we have to go with this non-economical supercritical condition method. Now, the other method to extract the nanomaterial which is along with the alcohol content is thermal evaporation. So at the room temperature only we can convert this gel into aerosol, but here the morphology is slightly changed. The size and shape of the nanomaterials which are going to be formed is varied, but it is economical. And coming to the third method by which we can extract the nanomaterial which is along with the alcohol content in the gel is calcination at 800 degrees centigrade temperature. Now what do you mean by calcination? Calcination is heating of the substance at high temperature in presence of oxygen. Now what is the substance which is being heated here? The nano-sized metal oxide. Whenever the nano-sized metal oxide which is a part of the gel which is along with the alcohol is heated at the temperature range of 600 to 800 degrees centigrade, whatever the alcohol content which is impregnated inside the nano-sized metal oxide gets evaporated, resulting in the formation of nanopowder. So according to the discussion, we can say that supercritical condition method is highly preferable, but it is not preferred over the other methods because it is not economical method. So most widely used method for the extraction of the nanomaterials which is along with the alcohol in the gel is this, students: calcination at 800 degrees centigrade or thermal evaporation. Now, let us see what are the chemical reactions involved in this particular wet chemical synthesis or sol gel method. So, initially we are taking the precursor. What is the precursor we are considering, students? The precursor is metal alkoxide. Now, this is dissolved in the alcohol. Alcohol is not reacting with that. The reason is, it is the solvent only. Now, after that, what we are doing? We are facilitating the hydrolysis reaction. That is, we are making the reaction between metal alkoxide, which is the precursor, and the water molecules. H2O Now, don't be in a dilemma. What is the product? Okay, what is the product? So I will rub this and I will write here clearly. Right. So this particular metal alkoxide can be written as. So see, among the what is R? R is alkyl group. Alkyl group means any methyl, ethyl, propyl group, right? Right. And among the alkyl group ion oxygen, which is electronegative. Oxygen is electronegative. Since oxygen is electronegative, it will bear the negative charge. It will bear the negative charge. O R, it will bear the negative charge. Since the one of the adjacent atom is bearing the negative charge, definitely the other atom will bear the positive charge. Bear the positive charge. So reacts with water molecule. And in the water molecule, already we know that it will be dissociated as H plus OH minus. H plus OH minus. H plus OH minus. Right. Now what happens? The negative ions will attract. The negative ions will attract the negatively charged ion, that is opposite charge. Oppositely charged ions will attract. The negative charge of one molecule will attract with the positive charge of another molecule and vice versa. Now it is M plus, students. So since it is M plus, it will react with OH minus, because it is M plus, react with OH minus. So what you are going to get? MOH plus OR minus and H plus. So minus takes positive. So ROH. So in this manner, you have to remember the reaction, but don't memorize. I will say this quite openly, but this is the thing which you will do actually. I hate this. Please don't memorize the reactions. Right. So next, what happens? So initially, hydrolysis reaction takes place, results in the formation of what, student? We are going to get the salt. We are going to get salt. We got the salt. So next, the salt will be converted into gel, because the gel is the starting material by which we can extract the nanopowder or zero cell or aerosol, right? So we have to see how the gel is going to be formed. Now, metal alkoxide reacts with metal hydroxide, which is the salt, and converts to. So dear students, see here again, metal alkoxide or plus metal hydroxide. So in metal alkoxide, oxygen bears the negative charge, metal bears the positive charge, and in this, hydrogen bears the positive charge, oxygen bears the negative charge. Now what happens? O, right? O minus takes M. So MOM. O minus takes M. MOM. So MOM is formed. What is MOM? MOM is gel. Gel. Plus, what is left, friends? OR minus and H plus. OR minus H plus. So ROH. So since the transformation of salt to gel is taking place during this particular synthesis or preparation of the nanomaterials, this particular synthesis is called as salt gel method. I hope you understood this particular synthesis, and this synthesis is very important synthesis for the preparation of the metal oxides, nano-sized metal oxides. So in the upcoming classes, I will discuss other preparation methods and the importance of or applications of the nanomaterials. So thanks for watching this video.